Hi, welcome to my video presentation. For my project, I chose to investigate properties of tessellations. I thought this would be interesting because I like to do art as a hobby, and a lot of art uses principles of tessellations, so I thought it would be interesting for me to learn more about this. The typical method for making a tessellation involves first making one of the three basic tessellating shapes, which are either an equilateral triangle, a square, or a regular hexagon. I chose to use a square for my example, just because they're the easiest to work with. So the first step is to cut a shape out of one of the sides. This is easiest if the shape you cut goes from one corner to another corner. In these examples, I created 4 congruent squares and cut the same shape out of one side of each of them to demonstrate the 3 possible transformations you can use. The first possible transformation is a simple glide. This involves moving the cut shape directly across to the opposite side. In order to tessellate this pattern, all you have to do is glide your tile. In this case, since the second pair of sides was already a glide, you can also glide side to side. The second possible transformation is a glide reflection. To create this transformation, you would take your cut shape, reflect it, and then finish the glide. In my case, I used a horizontal reflection followed by a vertical glide. To tessellate the shape, you follow the same pattern. You start with a horizontal reflection and then finish with a vertical glide. The final possible transformation is a rotation. To create this transformation, you would take your cut shape and then rotate it to an adjacent side. Unsurprisingly, to create the tile pattern, you perform the same rotation on your tile shape. Another interesting application of this is in computer art to make repeating patterns. A square will always tessellate, and a design drawn on a square will also tessellate. However, a drawing that doesn't cross any borders will create a boring grid. You could try to manually draw a design such that the edges will link up, but there's an easier way using rigid transformations. If you cut the square in half and swap the two halves, you will still have a square that will tessellate on the outside. But because the middle of the design is now on the edges of your shape, the edges of the pattern are guaranteed to match up. If you do this once more across the other axis, all 4 corners of the square will be involved in the pattern. Because the new center of the new tile is empty, you can add a new design there that will also tessellate because it will remain unbroken. This same process is used to make repeating designs for things like fabric and wallpaper, but another interesting application is for video games that use tiles for textures. This allows them to create patterns that have seamless repetition. As you can see here, the basic square is tiled over and over again, but the seams are very obvious, and this doesn't look very nice. We can get a better result if we use our pattern making technique to make sure that the edges of our square will all line up. We can then clean up the center of our tile to hide the obvious seams, and now when we loop our pattern, we get a much nicer result. Finally, I'd like to show you some patterns that I made using these tessellation techniques. First, I made these fish, and I made the basic fish shape using 2 simple glides, so one from top to bottom and one from side to side. I made this mouth shape using 2 rotations, and so I drew one side and rotated it 90 degrees, and then drew a second side and rotated that 90 degrees. And the waves are made using 2 glide reflections. So I drew the shape, used a horizontal reflection, and then glided it across the square. So what I learned from this project is that you can use 3 basic transformations and use this to make a large variety of different tessellating patterns. I thought this project was interesting and I had a lot of fun doing it. Thank you for watching.